Yes, dear student, now we have to discuss about second lecture of lecture on force. In the previous lecture, just we have introduced regarding force and impact of force. Right now, uh, I will discuss in detail, which could be up to class 8 standard. So try to understand. First of all, we have already gone through what is force. So force is a push or pull on an object. Uh, Force can be felt or experienced in terms of pull or push. It changes. This is the effect of force. It changes. Force changes or tends to change the state of rest or state of motion of an object by push or pull. Force itself is not visible, but effect of force can be seen or felt or experienced. Now, question is that how force come into play? So remember here, it is caused by an interaction between two objects. Remember, an interaction of one object with another object produces a force between the two objects. Then force comes into play. So remember, when asteroids moving in the space and no force is experienced by the asteroids and asteroids exerting no force on any other object, when these asteroids strike, collide with another asteroids, then force come into play. So when they interact with each other in terms of collision, then force come into play. Here we see a man push a car, a vehicle, then force come into play between man and vehicle. Man apply a force in terms of push on the vehicle, and so this is the example that force can come into play when two objects interact, either being in contact with each other or without being in contact with each other. So right now this is masculine force, so this is a contact force. Now question is that, next point we have to discuss, the force acting on an object in the same direction add up together, add up each other. So say in the previous class, just we have shown a picture in which several men in one group apply a force or pull in one direction. So all the force applied by each and every man in that group add up together and produce an effective force, large force. Now, if the force acting on an object are in opposite direction, then the net force acting on it is in the difference, is the difference between the two forces. If two forces acting in opposite direction, then net effect of force can be experienced as a difference of two forces. When all the two forces acting in the same direction, then the two forces add up together, because force is a vector quantity. That's why direction matters. The strength of force is called magnitude, where force consists of magnitude, direction, and in a magnitude, we need to know about the strength of force. Then strength of force is realized in terms of magnitude. SI unit of force is Newton, that was already discussed in the previous section. Now let us check out effect of force. So effect of force can be listed here. force can change the state of motion of an object. This is one effect. And in this case, we can see a force can change the speed as well as the direction of an object. Next, if the force is applied in the direction of motion, the speed of object will increase. On the other hand, if the force is applied in opposite direction of motion of object, then the speed of object will get decreased and ultimately object will come to rest if continuous force applied in opposite direction of that moving object. Next effect is that a force can change the shape and size of object. Here, look at. Force can change the shape of an object. That was discussed in the previous section and was shown as in case of a spring, rubber, and lemon, squeezing of lemon, twisting. All these were the example of shape and size changing. It can change the size of object. It can change both shape and size of object. So now next thing is we have to remember is that yes, types of force we have to remember here. Look at. Force can be divided in various types, but basic types are of two types based on whether they are in contact or not. So force can be divided into two parts, contact force and non-contact force. Contact force further subdivided into two parts, muscular force and frictional force. And non-contact force can be divided into three parts, gravitational force, electrical force, and magnetic force. So let us first learn about what is contact force. A force which can cause or change the motion of an object by physical touching, and such force is called contact force. As for example, muscular force is an example of contact force. When you push a cycle by being in contact with the cycle, then the speed of cycle increases or decreases. The force caused by the action of muscle is called muscular force. And the activities such as bending, movement, breathing, digestion of food involve muscular force. Activities such as bending, movement, breathing, and digestion of food all involves muscular force. The point where the force is applied on an object is called the point of contact. Next contact force is frictional force. So frictional force are responsible for changing the state of motion of an object is called frictional force. Frictional force is a type of force which always opposes relative motion between two surfaces in contact. It always acts on all moving objects in the direction opposite to that of the motion. It arises due to contact between two surfaces. If the surfaces are rough, then there will be more friction. As for example, when you walk on the ground, then the two surfaces, one of the surfaces is ground and another surface is the sole of your shoes that come in contact with, and then friction. Your shoes tends to push behind, and then the ground frictional force opposes that behind pushing. That's why we are able to walk. In absence of that friction, we can't be able to walk on the ground. So now to reduce friction, the surfaces in contact are kept smooth and polished. In that case, friction will be less. So next, non-contact force. Try to understand. Non-contact force, these forces act at a distance without being in physical contact. Such forces are called non-contact force. As for example, gravitational force, magnetic force, electrical force, all these are non-contact force. Because as for example, you know that Earth and Sun is not in contact with each other, but Earth and Sun attract to one another in terms of gravitational force, which is non-contact force. Similarly, two magnet you would see in your home. If you take two magnet, uh, and you will see that either they will repel or attract without being in contact. So types of non-contact force, magnetic force, first one. The force exerted by a magnet is known as magnetic force. Force exerted by a magnet on another object, magnetic object, or another magnet is called magnetic force. There is attraction or repulsion between the poles of the magnet. Therefore, magnetic force could be attractive or repulsive. Like poles of two magnets repel each other, on the other hand, a like pole attract each other. Here, example, this is the case of attraction, and this is the repulsion, because here repulsion, south and south repel, and south and north attract. Okay, a magnet can exert a force on another magnet without being in contact with it, hence it is known as non-contact force. Next one is electrical force. The force exerted by a charged body on another charged body or uncharged body is known as electrostatic or electrical force. It enables the charged substances to attract neutral substances. This is electrical force, due to which when you rub your comb against your hair and then bring this comb near the bits of paper get attracted towards the comb. While rubbing the comb against your hair, comb gets some certain amount of charge over it. And when it is brought near the bits of paper get attracted towards it. So next thing here, take a inflated balloon that is used in birthday party, and so just rub this balloon a little bit with your shirts, and then you will touch this balloon to the walls of your room. You will see that this balloon gets stuck to the wall without any glue or anything. Why? Because when you rub this balloon against with your shirt, a certain kind of charge is transferred from shirt to balloon or from balloon to shirt, and that's why balloon becomes charged. And when you bring this balloon to the contact with the wall, wall get attracted towards the balloon, and balloon get attracted towards the wall. This is the case here in this picture. Bits of paper has shown that when you rub the balloon and then put certain pieces of bits of paper there on the table, and then bring the balloon near that bits of paper without being in contact, you will see that bits of paper automatically get stuck to the balloon without being in contact, because balloon attracts the bits of paper towards it. Next one is substance with unlike charge attract each other, and those with like charge repel each other. This is also like electrical force, is just like magnetic force. Now gravitational force. Gravitational force is also a non-contact force, but this is different from magnetic force and electrical force, because uh, gravitational force is always attractive force. So gravitational force is defined as the force of attraction between two objects due to their masses. And this is, as for example, any object get attracted towards the center of the earth due to the gravitational pull exerted by the earth onto that object. We people are onto the earth. We can't escape out of the earth due to gravitational pull. Atmospheric air can't escape out of the atmosphere due to gravitational pull of the earth. So attraction of object towards the center of the earth is known as force of gravity, or simply gravity. The force act on all the object in the universe. This gravitational force is a universal force and act on all the object. Everywhere, wherever object will have mass, because we know that without mass object can't exist. So wherever a particle will have mass, they will attract each other. Every object in the universe, whether they are small or large, exert a force on one another, and this force is called gravitational force, and that's why gravitational force is called universal gravitational force, or universal law. In the next class, we will discuss about pressure. So here, a little bit, try to understand what is pressure. Pressure is the force per unit area. So far we have discussed about force. So now we have to remember about pressure. Pressure is the force acted upon an object of unit area in a direction perpendicular to the surface of the object. So simply we can say pressure is defined as force per unit area, yeah, force acting per unit area in a direction perpendicular to the surface of the object. It is mathematically given as pressure equal to ratio of force and area of the object over which force is acting. It is also defined as the thrust, because perpendicular direction is confined. That's why force which act perpendicular to the surface is called thrust. So pressure can also be defined as thrust acting per unit area. Example, a force applied perpendicular to the board. Here, look at a force applied perpendicular to the board. Here, board is here, and a pin is taken. And from the tip of the pin, from the top of the pin, a pressure force is applied in terms of push by the thumb. And the other end, tip of the pin is of a smaller area in comparison to top of the pin. That's why the tip of the pin get entered into the board by applying a force by the thumb. So for pressure, we have pressure is directly proportional to the thrust or force. More is the force, more will be pressure. More is the thrust, more will be the pressure. Next, pressure will be inversely proportional to the area on which the force is applied. Here, this is the area. So here you see that area, it is inversely proportional to area. Area will, if increase the area, effect of force will decrease, that is pressure will decrease. And if you decrease the area, effect of pressure will increase, or that is effect of force will increase. So lesser the area of contact, more is the pressure. And more is the area of contact, less will be pressure. Example, heavy trucks have 6 to 8 tires instead of the conventional 4 in order to increase the area of contact. Heavy trucks which carry heavy loads have 6 to 8 tires instead of conventional tires 4. Why? Because to increase the area of contact with the road so that pressure due to heavy load get decreased. Thus, the pressure on the ground is reduced. A camel can walk easily in the desert as compared to the other animals because they have a broader feet which exert less pressure on the sandy ground, sandy land, and enabling them to walk properly. Therefore, skiers use a long flat skies to slide over the snow. Skiers use long flat skies to slide over the snow due to increasing area. The larger the area of the contact, the lesser is the pressure on the snow, and this helps the skiers to slide comfortably without sinking into the snow. And now come to the point. SI unit of pressure is Newton per meter square and abbreviated as Newton per m square or Newton m to the power minus 2. Liquid and gas also exert pressure on the walls of the container in which it is contained. Air exerts pressure on all objects and it is called the atmospheric pressure. A liquid exerts pressure on the base of the container because of its weight. And if the molecules of liquid are in motion, then they strike or collide with the walls of container. In every collision, these molecules exert a thrust on the walls of container and hence exert a pressure even on the walls of container. But if molecules of liquid at rest, then it exerts only pressure onto the base of the container. Characteristics of liquid pressure, try to understand. Liquid pressure increases with depth. As depth increases, liquid pressure also increases. As you have seen that in a container filled with water, if you make a hole at anywhere near the bottom of the container, you will see that water comes out from the container with higher speed, and on the other hand, a hole made at the top or at the middle of the container, water comes with a low speed. It remains the same in all the direction of at that given depth. Liquid pressure remains same at a particular depth where depth is kept constant. Next, liquid pressure also depends on the density of liquid. More is the density, more will be liquid pressure here. A liquid exert a pressure on the sides of the container, and liquid seeks its own level. A liquid seeks its own level, and no matters where you put any shape of container, liquid level will remain same because to have same pressure. Atmospheric pressure, to learn about atmospheric pressure, the earth is surrounded by a layer of air up to certain height, and this layer of air is called the atmospheric pressure. Because a weight of air exerts a force on the surface of the earth and everything on the earth, that's why it is called atmospheric pressure. As we gradually move up, and up, the density of layer of air decreases, and at particular height, it reduces to zero, and pressure becomes zero at that layer. Air has mass, so it exerts a force on the Earth's surface. and on the different object. This force acting on a unit area is called atmospheric pressure. That is, weight of the air in the atmosphere per unit area is called atmospheric pressure. Atmospheric pressure is the weight of air in a column of unit area. Next, atmospheric pressure is decreases as we go up in the atmosphere. That's why if someone rises, go to the peak of the Himalaya, nose bleeding starts up because at the peak of the Himalayas, which is at a higher altitude than sea level, there will be low pressure, and that's why nose bleeding starts. SI unit of pressure is Newton per meter square, and this Newton per meter square is also called Pascal. Pascal was a scientist and who studied a lot and gave lots of law related to the pressure. Therefore, this unit Newton per meter square were named as Pascal. The pressure inside our body is equal to the atmospheric pressure outside. So we are not crushed because of this air pressure. If we go in the vacuum or in the space, our body pressure will be maximum, but outside pressure is zero. That's why our body will blast in the same way as balloon blast. So next thing is today's class is over for this, and we will discuss